Another aspect of plant biology that can help you manage these grasses is knowing the growth curves. That is, how that forage production is distributed across the growing season. Now here at the University of Tennessee, we did several grazing trials that allowed us to do just that, create these growth curves for these native grass forages. The way we did that is something called put and take stocking. So what we do is we try to maintain that pasture at a consistent grass height, and then we add or take away animals as needed to maintain that grass height. And then we can see how many animals we had out there at different times, and that lets us know what that growth potential of that grass was. So let's take a look at those curves and see what that can tell us about managing native grasses. So let's start off looking at the growth curve for switchgrass. Now this is for a lowland switchgrass. Alamo is the variety. This curve here is based on 3 years of grazing study on numerous pastures, and these pastures every spring receive 60 units of nitrogen. So that's the basis for this curve. And there's 3 things I want you to notice about this curve. Number 1 is the carrying capacity is really very high. This is a very high yielding grass. Number 2, we see this remarkable surge in growth that occurs in late spring, early summer. And then number 3, that curve tails off as the growing season goes on. Now let's add to that our Easterngamagrass curve. Now one thing that should jump out at you immediately is that Easterngamagrass curve tends to be more level than the more eruptive switchgrass curve. The other thing to notice is the carrying capacity is not quite as high, but this Easterngamagrass curve was also developed from multiple pastures over 3 years, but received no nitrogen at any point during those trials. So if we were to add nitrogen to that gamagrass, we can expect that that carrying capacity would be higher, particularly because gamagrass really responds well to nitrogen. So probably in the scheme of things, its carrying capacity would really approach that of the lowland switchgrass that you see right here. Now the third curve that we want to look at is for our big bluestem Indian grass blend. Now this has the lowest carrying capacity of the 3, but like the Easterngamagrass, is fairly level. It doesn't have that big eruptive pattern of switchgrass. Also, I want to point out that this big bluestem Indian grass blend, like the switchgrass, receives 60 units of nitrogen every spring during the duration of the study. There's one other thing I want to show you about all 3 of these curves that they have in common. Each of these curves shows a shift in the growth pattern of the grasses that occurs roughly in midsummer. So for instance, in switchgrass it's more pronounced, and it occurs almost reliably about June 20th each year because it's driven by daylight. But all 3 grasses at this point show a shift in their growth strategy. They go from producing vegetative material to going reproductive. So instead of growing more foliage necessarily, they're starting to try to grow seed heads. Now the important thing about this is that as a forage manager, you need to be prepared for 2 things. 1, the slowdown in growth rate, and 2, that plant's determination to get reproductive. So what you have to do then is balance your grazing management during that period of the summer to keep those plants vegetative